The sine law can be used to find missing measures of angles and missing side lengths on triangles that aren't necessarily 90-degree angles. So if you take the triangle A, B, C, we always put capital letters on the points on the triangle because we want our angles to be capital letters, with the side lengths lowercase a, lowercase b, and lowercase c. The A is always going to go across from your A, same with your B and your C. So the sine law says that for any triangle ABC, A over sine of A is equal to B over the sine of B, which is equal to C over the sine of C. So we can use these ratios to solve for any missing variables. It also means that the flip, so sine of A over A equals sine of B over B, and sine of C over C. To prove that this is the case, first you need to take a perpendicular line from C down to AB. So this makes 90-degree angles. So we can call this length H, this length B, and this length A. If we want to write H in terms of B and a trigonometric ratio, we want to use from this angle this side, which is our opposite, and B, which is our hypotenuse. So we have an O and an H, so we're going to use sine. So sine of A equals H over B. We want H to be by itself, so we're going to multiply both sides by B. So B sine of A is equal to H. Same thing as if we want H in terms of A and a trigonometric ratio. So we want to go from angle B. So our opposite is H and our hypotenuse is A, so we're using sine again. So sine of B is equal to H over A times both sides by A, and we're left with A sine B equals H. Now because we know they both equal H, we can say replace this H with that. So we can make them equal to each other. So B sine of A is equal to A sine of B. Now we want this to look like our sine law. So what I'm going to do right here is I'm going to divide both sides by sine A, sine B, because I want to switch the sides. And what ends up happening is this B cancels and this A cancels, and all you're left with is B over sine B equals A over sine A. And if you want a proof of why it equals C over sine C, it's on page 470 and 471 in the textbook. So applying the sine law means that we can find a missing length or side. So for this one, we want to find length GH. So that's the same as side J here. So our first step is we want to fill in our A, B, and C in our ratio, and we want to have our angles on the bottom. So instead of writing A, B, C, we have G, H, and J. So let's start with J. So side J is over sine of angle J, which is 44 degrees. We're going to set this equal to H, so H over sine of H, which is equal to G, which is 7.8, over the sine of 51 degrees. Now we want to pick our two ratios so that we only have one variable. So we want to use this one and this one because we want to find J. So j over sine 44 is equal to 7.8 over sine of 51. We want the j by itself, so we're going to multiply both sides by sine 44. So we're left with j is equal to 7.8 times the sine of 44 divided by the sine of 51. So if you multiply this out and solve on your calculator, you should get j is equal to 7.0 centimeters. And we want to round to the nearest tenth. So that is how you solve for a length. The sine law can also be used to find the measure of an angle. So it's the same thing. First, you're going to set up your ratios, but this time you want to have your angles on the top. So we have m and p instead of a, b, c. So let's start with m. So sine of 92 degrees over 11.8 is equal to n. So sine of n over little n. So this will be n, which is equal to the sine of p over 10 centimeters. So we want to find angle n to the nearest degree. Because we can't directly find angle n because we don't know its length, first we have to find angle p, and then we can use that to find angle n. So we're going to choose this and this. So sine of 92 degrees over 11.8 is equal to sine p over 10. We're going to multiply both sides by 10. So we have 10 sine 92 over 11.8 equals the sine of p. So then we have to take sine to the negative 1 of 10 sine 92 divided by 11.8. So if you type this all into your calculator, you should get 58 degrees equals your p. So this is 58 degrees. Now we want to find n. And because we know that all angles in a triangle add up to 180, all we do is for n, we go 180 minus 92 minus 58, and we get that n is equal to 30 degrees. So for our last example 3, we want to solve the following triangles. So that means we want to find all the lengths and all the angles. So let's first do the angle, so it's easier. It's easier to solve your angles first. So we want to find angle f. So sine of f over 5, which is our side length for f, is equal to sine of d, which is 80 degrees, over our side length, which is 8, because it's across from d, which is equal to sine of e over e. And this is our e. So we want to use the first two. So we're going to get f by itself, so we're going to multiply both sides by 5. So sine of f is equal to 5 sine 80 divided by 8. And then we have to solve for f, so sine to the negative 1 of 5 times sine 80 divided by 8. If you type this into your calculator, you should get 38 degrees. Because we know the one angle, we can also find angle E. So we just go 180 minus 38 minus 80. So this is for angle E. And we get that angle E is equal to 62 degrees. So now we have all of our angles. We can now find our sides. So we want to find the little e. So e over sine of 62 degrees. And we can make this equal to either of our ratios. So let's make it equal to d. So d is 8 over sine of 80. Now we can solve for e. So we're going to multiply both sides by sine 62. So e is equal to 8 sine 62 divided by sine 80. And when you multiply that out, you should get 7.2 centimeters. Now we have all of our side lengths and all of our angles, so we are done. This triangle is solved.